Can anyone confirm am I audible or not?
Yes, I know.
Thank you. So we will start our lecture today. So welcome everyone, and today is the week 8th of this tutorial session of Deep Learning IT Ropar course. And today we will discuss most of the important question from the week 8, uh, whatever taught in the week 8. And from next week I will be taking on Saturday only. Just this week I have taken on Tuesday, that is 6 to 7 p.m. So the first question that is based on the gradient, like which of the following is correct for the given model? So the first question is based on the update rules. So that is the first statement given is the update rule for W is W equal to W minus eta delta W. So this option is correct. Second is delta W depends to the input to the network. We will see about this. We will see the concept. And third, that is delta W learning algorithm is gradient descent. So before that, we will see like what is the formula for delta W. We all know our update rule is given as this. Okay. And this gradient of W that depends on input. Like the formula for this is gradient of W is the derivative of loss function with respect to W. And this is given as Fx into 1 minus Fx into x. Okay, so this gradient of W depends on the input x. Okay, so the option 2 is also correct. So it depends on the input. And how do we learn the W? Using the gradient descent algorithm. So all the three options are correct. So in the first question, so all three options are correct in the first question. So option D is the correct. Also, you can comment your answer before me if you know the answer in the chat box. And if you have any doubt, then you can ask in chat box as well, or even by unmuting yourself. Okay. So this is just a simple question depending on the update rule. So how this was the formula for our update rule, and it depends on the input x. So now we'll move on to the next question that is based on the regularization. So in this question, it is given there are L1 regularization and L2 regularization, and it is a match of the following question. So if anyone know, you can just give the answer in the comment box. So in the left side, L1 and L2 are there. In the right side, we will see which one is matching properly. So we all know that regularization constrain the weights to certain regions of the parameter space. Okay, and in L1 regularization, it constrains most weight to be 0. And in L2 regularization, it prevents most weights from taking large value. So these concepts we know. So based on this, we'll see for L1 regularization which option is correct. The first one allows weight to span over the entire parameter space. So this is wrong because regularization constrains the weight to certain regions of the parameter space. Okay. Someone commented, yeah, option B, that looks correct. B is constrains most of the weights to 0. So yes, this is correct for L1 regularization. So 1 is matching with B. Now coming to 2, the first one is wrong for both of them, A option. Now C, you can see concentrate most weight from taking large value. So this is done using L2 regularization. So in this question, one first 1B and 2C is the correct option for this question. So option B is correct. Now we'll move on to the next question. If you have any doubt, you can ask. Now coming to the unsupervised pre-training. So before solving this question, we will see what is unsupervised pre-training. So in this question, we have to identify the correct statements. That statements are given as unsupervised pre-training initializes random weights. And second is unsupervised pre-training requires fine-tuning weights using a supervised objective. So before that, we'll move on to this. So in the left side, this is our network. So what happened in unsupervised training? Like first we take the weights in the layer one, like we take the this part only, the part which is in the red box, this part. And what we do, the weights in the layer one are trained such that H1 captures an abstract representation of the input X, like and after that, at the end of these steps, the weight in layer 1 are trained. Okay. And now we fix that weights in the layer 1 and repeat the same process with the layer 2. And we do this process up to end when the all the weight layers are getting trained. So after this layer wise pre-training, we add the output layer, like when we get all the weights in the different layers. So after getting all the weights trained in different layers, what we do, we just add the output and train the whole network using the specific objective, and then some fine tuning is required. Okay, in this fine tuning is required because we are adding output also. So now we'll see. The option 1 says that unsupervised pre-training initializes random weights. This is wrong. It does not initializes random weights. It's uh, it is training, like first it is taking the first layer and then getting the weights of the layer 1, and after that it is getting the weights of all the layer uh, by using the auto encoders method here, as you can see. So in this way, all the weights when you get, then after that, it's add the output layer and train the whole network, and just after the fine tuning, the output with minimum loss can be derived. So option 2, unsupervised pre-training requires fine tuning weights using a supervised objective. So option 2 is correct. So the option B is correct. Yeah, correct. Some of you answered option B in the chat box. So this option is correct. So any doubt in this? Anyway, this video will be also recorded and uploaded on YouTube. So even after you have not attended the class of week 8, then you can attend it and again see this tutorial session. But if you will see now, then also you will get some of the basic concepts clear. Now we'll move on to the question 4, that is based on activation function. So for a deep neural network shown below in this figure, assume that all sigmoids are replaced by linear functions. Comment on the decision boundaries of such a model. So in this question, you can see here that all sigmoids, here the sigmoids neuron that is replaced using the linear functions. So what will happen after that? When the linear function is there, then we'll see all the options first. Model cannot learn linear decision boundaries. That is wrong, because if linear function can easily learn the linear decision boundaries, because that is the most easiest boundary to classify the objects. Model can learn an arbitrary decision boundary. This we'll see. This is wrong because it cannot learn all the non-linear boundaries like when we have already studied in the week one. Let's suppose there are two different kinds of objects given by this black and red. So this can be separated using the circular path. That cannot be done using the linear function. Model can learn both linear and convex decision boundaries. This is wrong. Model can learn linear decision boundaries but cannot learn arbitrary. So option D is correct because it can learn linear decision boundary and cannot learn other arbitrary. So option D is the correct option. Yeah, correct, Bhushan. Option D is correct. So any doubt in this question? So now we'll move on to the next question. So we'll move on to the next question that is based on the ReLU activation. So identify the advantages of ReLU activation function. So it is computationally expensive. First we'll see what it is. So this is the curve for the ReLU activation function, that is fx is equal to maximum of 0 comma x. So in this, like for x that is negative, that is from less than 0, the fx will be 0. Okay, for x greater than 0, fx will be x. So this is same as maximum of 0 comma x because all negative numbers are less than 0. Okay, because see, when x is equal to minus 3, then our fx is equal to maximum of 0 comma minus 3. So it will be 0. So all for all negative x, fx is equal to 0. And for positive x, fx is equal to x. So this is our ReLU function. And this is computationally expensive, wrong, because this is a uh, very less expensive as you see in terms of computational complexity, because the other sigmoid and all includes exponential functions, does not saturate in positive region. This is correct because this curve does not saturate in positive region. Okay, as you can see in other curve like sigmoid and all, this will saturate in the positive as well as negative region, but this is not saturating, it will increase continuously. Okay, so option B is correct. Converges faster than sigmoid function. Option C is also correct. ReLU neurons die if the learning rate is uh, set high. Yet it, yes, it die, but this is not the advantage. This is a disadvantage. So this is the disadvantage of ReLU function. Just there was a twist in this question because you have to correct the advantages. So option B and option C is correct. In this is just a multiple choice select question. So sorry, this is MSQ. Not only one option is correct, two options are correct, option B and option C. And the option D is the disadvantages of ReLU function. That's why we will exclude that. Okay. So let's suppose like we'll see some more things in the ReLU. We'll see first the derivative of this. When you do derivative, so this will be 0 if x is less than 0, and this will be 1 when x is greater than 0. Okay. And there is one problem with the ReLU network, like this is our input layer, this is our hidden layer, and this is the output layer. Okay, so in this case what happens, Like when our this bias is very very large negative, any variation of ReLU is expensive or not? Yeah, one of the variation, like some variation of ReLU includes exponential function. Those variations are expensive. This was just a simple. This is non-linear only, but from when x is greater than zero, it acts as a linear curve. So that is a very simple, inexpensive. Like it using exponential terms, right? So if you do those derivatives, it will include lots of exponential term in back propagation also. So those are computationally expensive. And this is simple. Fx is equal to x. Doubt clear? So what happens? Like you can see in the first here that w1 x1 plus w2 x2 plus b. Yeah, someone is unmute. You can speak.
Yes. But what is this? When the learning rate is there also uh, network will be higher and closer to zero.
Like some of the neurons does not react in that case because that does not give the output to the next layer. So those neurons are died.
When the learning rate is negative of it.
Yeah, when bias gets the like more negative value.
Now, among these two, which one is because when assuming one of the disadvantages, I mean, in my opinion, both are disadvantages. So once the learning rate is higher, that is also a disadvantage.
Yeah,
And
both.
another one is when the bias receives larger negative uptake, it is also disadvantage.
Yeah, that is also disadvantage. Like for different values, both are disadvantages only. So like we can plot the curve for different values and check for which condition which is like giving the higher disadvantages.
But
It depends on values also.
my- it means you are supposed to mark only one disadvantage. So I get an average here.
So like right now I'm not clear about this, which is like more disadvantageous.
Okay, sir.
So you can ask in the comment of the like course, there will reply. I will reply after this session.
Okay, sir.
Because it depends on the value also, like how much values we are setting for.
Ah,
Some questions are ambiguous, so accordingly you can see in the assignments.
okay.
So in this case, if b is like very negative, then like b is much less than zero, then this whole term will be negative. Okay, and like then this neuron will not fire and it will be just like a died neuron. So it will not participate later on, and this will like the weights and other parameters will not get updated because the derivative will become zero. So in this case, this is the disadvantages when you set the learning rate or even the bias is more negative. Okay. So for this question, option B and C are the correct, and A and D is not the correct option. So now coming to the next question, and also one more thing, like in this question, the negative part we can use some leaky ReLU so that it is not converging on the negative part also. Like most of the time when if converges in negative part, then also the derivative will be zero and the parameters will not get updated, and those will also lead to the some of the neurons to die. So we will discuss one question based on the leaky ReLU also. at the end. So now coming to the next question, that is activation function. Based on the activation function, that is identify the function with following characteristics. Compresses the values to the range -1 to 1. So which one is that? Like linear is not -1 to 1. So this will be scan h. Yeah, correct. And sigmoid is from 0 to 1. And ReLU is also from normal ReLU is from 0 to x, but 0 to x. So -1 to 1 is tan h. Inputs are 0 centered. So this is also the properties of tan h. So third is gradient vanishes to 0 on saturation. Yeah, it's means the at when the x is very large or x is very negative, at that time the gradient is 0 in tan h. So option 3 is also correct for tan h, and it is computationally expensive. Yes, this is computationally expensive because it's a non-linear function. So option B is correct. This is for tan h. Okay, and even gradient vanishes 0 for sigmoid also, and sigmoid is also computationally expensive. But we have to see which option is satisfying all these statements. So option B is the correct. Okay. So any doubt in this question? So now we'll move on to the next question, that is question 7. That is, assume that there is a large negative bias and the ReLU neuron dies. Pick out the upcoming state for the dead neuron. So once the when the neuron died, it remains dead forever because once you got the derivative 0, again when you will multiply and derive, it will get 0 only. So after that it will not be active, so it will remains dead forever. So option B is correct. Option A is becomes active, that is wrong. Regains active immediately, that is also wrong. Starts learning reversely, it stop learning after getting dead. So option B is the correct option for this question. Now coming to the next question, that is based on the symmetry breaking. So we'll see what this problem is. When does symmetry breaking problem arise? If all the weight in the network are initialized to the same value, if we initialize all weights to 0, both and none. So before that we'll see, like here you can see that this is our network, and in this let's suppose if we initialize all the weights to 0. Okay, so all neurons in layer 1, here you can see A11 that is equal to this A11, this is equal to W11 into X1, okay, plus W12 X2. This is W11, this is W12, and this is W21 and W2. This is W22. Okay. So here you can see A11 is equal to W11 X1 and plus W12 X2. Similarly, A12 is equal to W21 X1 plus W22 X2. So what will happen? Now our A11 will become 0 because we are initializing with all weights as 0. So in this case, W11, W12, W21, W22 is equal to 0 because initialized as 0. So after that what we will get, like if A11 and A12 is 0, here H11 that is equal to sigmoid of A11, that is equal to sigmoid of 0, and H12 that is equal to sigmoid of A12, that is also is equal to sigmoid of 0. So this H11 is equal to H12. So in this way what happened, like in all the layer all the values will become 0. Like when you do find the gradients, All right. So gradient is just the like derivative of the loss function. We using the chain rule. If you write like this, and the input x1, okay, and for you, if you write for another w21 parameter, again you will get like this into x1. So as you know that like this h11 and h12 is equal, so this term is equal, this term is equal, this all terms are equal. So in this case what happen, all the weights will become equal. And even if the same, like if you take all the like initial parameter, that w11 w12 w21 and w22, if you initialize all the weight as same also, in that case also like when you update, all the weights will get update together and remains equals, okay. So this symmetry will never break or converges. So the same is like for then in the all the next layer also, uh, means like all the value of these weights will update together. It will not change, because if you add in this formula, if you see in this formula, these all values are equal. So there is no use, and this is the problem of symmetry breaking down, and the weight will never get updated separately. So
Sir, so this means the area for zero or for equal value. Suppose if you assume all weights equal to 0.5 also, the
yeah,
symmetry rating will occur.
yeah, correct.
Okay.
Correct, because see here also, if this del h1 and del h2 will become same, and this derivative will become same, so this will be equal, and this gradient is equal, then in the update rule also it will be,
Equal.
sorry, it will be equal, because this gradient it depends on the gradient. So if we are gradients are getting equal when the weights are initialized as 0 or as the same value. So now we will see for the next question, that is based on the leaky ReLU. So like there is a problem in the normal ReLU, that for negative side, like negative axis on the x-axis, what happens? The derivative is equal to 0. So most of the neurons die out. So this problem of dying of the neurons can be solved using the leaky ReLU. So there is a small negative slope is added. That is, let's suppose in this case y is equal to 0.01x. For x is less than 0, y is equal to 0.01x. So instead of not firing at all for large gradients, our neurons do output some value, because there is a small 0.01 into x is there. When you do the derivative of y with respect to x, you will get 0.01. So it will just fire the small output value, and that makes our layer much more optimized too. So it's just prevent the problem from the dying out of the neuron in the ReLU activation function. So for today, we will have this much only as a tutorial session. So we'll meet on the next Saturday, and like if you have any doubt, then you can ask in the comment section of the classroom course also, and even on the updated lecture. Uh, that is, this recorded lecture will be uploaded on YouTube as well. So there you can ask. So thank you everyone for attending this session. We'll meet on the next Saturday at 3 to 4 p.m. And Raghupati, you can ask that question there. I will little see about that, like which is more disadvantageous, and will reply back.
Okay, sir. Thank you.
Okay. Because I have not worked upon that, so I feel like right now I cannot answer, which is like giving the more difficult.
Okay, sir.
Okay. Thank you. Thank you, everyone.
Okay, sir.
Okay. Bye bye.